There are lots of machines that are CAM machinery. A fantastic example of this is a laser cutter. A laser cutter takes its instructions from the CAD drawing and knows exactly how to cut out the piece of material that it's presented with. The information of how deep to cut, how far to cut, is contained within the drawing itself. It can tell the laser what sort of material it's working with and whether to cut through fully or partially the material that's underneath. This, of course, is set all by the designer at the CAD stage and takes much practice to enable them to understand exactly what instructions they're giving the laser. A 3D printer also is an amazing design machinery that enables us to produce products using CAM. The drawing in the CAD stage translates the information to the 3D printer, which then interprets that with materials. Lots of materials are being explored currently by designers, and the use of CAD CAM is being translated into lots of new avenues. Some of the more recent concepts are shown on the screen. Making body parts from a 3D printer, like replacement hips and prosthetic limbs, are an amazing use of a predominantly industrial process. Using them to help people get back on with their lives is a fantastic achievement. Using a 3D printer and replacing the plastic material with food, the food industry is able to explore different ways of producing new and alternative shapes. In the world of shelters, emergency aid, certain companies are exploring the use of 3D printers to create concrete shelters that can be quickly erected in times of crisis. During the recent COVID-19 struggles, lots of small pop-up businesses decided to use their 3D printing machines to create face shields for the NHS. These are just some examples of what CAD-CAM can do and are very, very small samples. There are huge and vast ways that this can be used in industry. Here are a couple of videos.
I'm the CEO of Bionic, and we're using 3D printing to create prosthetic limbs. At Bionics, we're creating the next generation of prosthetic limbs. I like to compare a prosthetic to a shoe because it has a very similar function. It's something that you wear over part of your body. You have to wear it all day long, and it has to be very comfortable. You have to like the way that it looks and be comfortable wearing it both physically and socially. The product that we're developing at the moment, which is the Bionic Hand, is for transradial amputees. These are people that have an upper limb difference where they still have some of their forearm, but they may be missing anywhere from their hand upwards. So they still have an elbow joint, and this is where the prosthetic socket connects to their arm, but they don't have a hand. We have sensors that we place on the wearer's muscles in their arm, and when they flex their muscles, we detect an electrical signal from the surface of their skin, and that's what makes the hand move. The hand itself has control of each finger independently, and the wearer can give it commands to do different things, so they can move the fingers of the hand with varying power and speed. So they can move it really slowly or quickly and with a lot of power. And they can switch between different gripping modes, so they can do like pinch grips and tripod grips to pick up smaller objects and do fine tasks. We use our multi-makers to print all of the manufactured parts inside of the hand. We have the actuators, that's a component that we buy, the circuit boards we've designed, and we get those made externally. But then all of the mechanical components, we 3D print using our multi-maker printers. We use two different materials at the moment, so we have PLA plastic and a TPU called NinjaFlex, which is like a flexible plastic. So we use a combination of those for different parts of the hand that need to be soft or rigid. We use the flexible parts for the joints of the fingers, and it means that we don't have loads of different parts to manufacture either. We can print the finger as an entire unit with all of the joints built in, and then it just works straight off the print bed. It's so awesome seeing the reactions from people wearing it for the first time and trying it out for the first time. Some people have never worn a Bionic Hand before, and seeing the satisfaction on their face when they get it to move is really, really cool.
Not far from Chocolate and Cocoa Avenues in Pennsylvania, American chocolatier Hershey experiments down these halls with a well-known confection.
You know what this is. This is a Hershey Kiss. It was first produced in 1907, but more than 100 years later, we're getting a high-tech take on this traditional piece of chocolate. And the magic is happening right in here.
1 hour, 26 minutes. The time to 3D print one Hershey Kiss.
The chocolate's being heat up there in this white cabinet here.
Right.
And it's pushed through that small muscle.
Shapes in 3 dimensions. Computer designed, then extruded like icing out of a bag, layer on layer. Industrial firms have used such methods with metal, plastic, and other media since the first commercial 3D printer in 1989 by 3D Systems. Only recently has food been tried.
I don't